Okay, so we're going to look at some examples of area under a curve, and this is following calculus curriculum. So the first one says, evaluate the integral from 0 to the square root of 7 of 9x squared times the square root of 1 plus x squared dx. So the first thing I'm going to do is I'm going to prep this in order to start u substitution. So I'm going to first take out the constant 9, so I have 9 integral 0 square roots of 7, and then I'm going to separate the x cubed into x squared times x, and then I'm leaving the square root of 1 plus x squared dx. And again, I'm prepping this for u substitution. So I'm going to let u equal 1 plus x squared. Typically for u substitution, anything under a radical is going to be your u, okay? I'm then going to take the derivative of this, so I get du is equal to 2x dx. And then from here, I want to make sure that I'm changing my limits on my integral to correlate with my u substitution. So since I'm saying that u is equal to 1 plus x squared, I am going to have 1 plus 0 squared on the bottom and then 1 plus square root of 7 squared on the top, which means my integral is now from 1 to 8. Okay. Now I am going to plug everything in terms of u. And so what I have here is I still have that 9 that I took out in the beginning. I have the integral of 1 to 8. And instead of x squared or x, I'm going to write u minus 1. Okay, and sorry, I didn't mean to write mu. It should be u minus 1. And then, of course, instead of 1 plus x squared, this is going to be the square root of u. And then since my derivative of u, my du, gave me 2 times x, I don't need that 2 in there, so I'm going to end up dividing everything by 2 when I multiply the du. So in this case, I have everything substituted in terms of u, and I'm just going to continue on and solve this integral. So the first thing I'm going to do is I'm going to take out that 2. So ultimately, since it's on the denominator, it's a 1/2. So now on the outside, I have 9/2, integral of 1 to 8. And instead of leaving this as u minus 1 times the square root of u, I know that the square root of u can be written as u to the 1/2 power. So I'm just going to distribute that into the u minus 1. Which means I'm given u to the 3/2 power minus u to the 1/2 power du. Okay. And since they are now subtracting from each other, I'm able to take the integral and then calculate that from there. So I'm just going to take the integral of each one. So first, starting out, u to the 3/2 power, I need to add 1 to the exponent and then divide by that new exponent. So if I add 1 to 3/2, that is going to be the same as adding 2 over 2, which becomes 5/2. So now I have 9/2 times u to the 5/2, and if I divide by 5/2, that's the same as multiplying by 2/5. Okay. Doing the same thing for u to the 1/2 power, I get 2/3 u to the 3/2 power. And then now I'm solving this from 1 to 8. So then I get 9/2 times 2/5 times 8 to the 5/2 power minus 2/3 times 8 to the 3/2 power minus 9/2 times 2/5 times 1 to the 5/2 power minus 2/3 times 1 to the 3/2 power. And this gives me, I just typed this whole thing right here into my calculator. And this gives me 259.35 as the area under that curve. Okay. The next example here says find the area of the shaded region. Okay, notice that it gives you the equations and it gives you the places that it intersects. This is important when having to write our integral because we need those intersection points. So they did a hard part for us by already giving us that graph. Okay, so the first thing I'm going to do is I'm going to look at my graph and notice that my linear line here, the one that's in green, this is representing g of x. And then my parabola here, what's in blue, is representing f of x. Well, looking at the area, I see that g of x from -1 to 5 is on top. So I'm going to do g of x minus f of x. Okay, so we're going to use that when setting up our integral, and we're going to be using the -1 to 5 to set this up. Okay, so I have the integral from -1 to 5 of g of x minus f of x. So this is 44x plus 105 minus x to the 4th minus 12x cubed plus 48x squared. And then I'm going to simplify this, and I get the integral of -1 to 5 of negative x to the 4th plus 12x cubed minus 48x squared plus 44x plus 105. Okay, and of course, dx at the end. Okay. And all I did from that first step to the second step is just combine like terms. Okay. Now I'm going to do the integration of each part separately, and remember that's just us adding 1 to the exponent and then dividing by that number that we get. So that is going to give me negative x to the 5 divided by 5 plus 12x to the 4 divided by 4. Notice how my exponents are just increasing by 1. Minus 48x cubed divided by 3 plus 44x squared divided by 2 plus 105x. So if I don't see a variable there, I'm just going to attach it to the end of that constant. And then I'm solving this from -1 to 5. So then plugging this in, I get -5 to the 5th power divided by 5 plus 12 times 5 to the 4th power divided by 4 minus 48 to the 5th power cubed divided by 3 plus 44 times 5 squared divided by 2 plus 105 times 5 minus, and then I'm plugging in the same thing but now -1, so -1 to the 5th power divided by 5 plus 12 times -1 to the 4th power divided by 4 minus 48 to times -1 to the 3rd power divided by 3 plus 44 times -1 squared divided by 2 plus 105 times -1. Put that entire thing in your calculator. Just be very careful since we do have fractions here and exponents. Make sure everything is typed in correctly, and you get 388.8 as the area of the shaded region provided. Example 3. So in example 3, notice they give us 2 equations, but they don't give us a graph and they don't give us any of the intersections. So that's what we're going to have to do first. So first I'm going to find the intersections. So notice they're both equal to y, which means I can set them equal to each other. So 4x plus 12 equals x squared. Since this is quadratic, in order to get my intersections, I'm going to have to get everything equal to 0. So I have x squared minus 4x minus 12 equals 0. Then I need two numbers that multiply to -12 but add to -4, and that would be -6 and +2. So that means I would factor this into x minus 6 times x plus 2 equals 0. And then my intersections is just setting them separately equal to 0. So x minus 6 equals 0 implies that x equals 6, and x plus 2 equals 0 implies that x equals -2. So now off to the side, I'm going to draw a graph here. So I know that I have a quadratic here. So this is my y equals x squared. And then I know I'm going to have an intersection here at -2 and then around here at 6. So this line here is going to represent my y is equal to 4x plus 12. Notice that it wants us to find the area between these. So in order to do that, I have to acknowledge that the linear equation is on top of the quadratic equation for the boundaries -2 to 6, which means when I set up my integral, it would be the integral from -2 to 6, and I would take the linear function, okay, and then subtract the quadratic function. So let me go ahead and label this f of x and this g of x. It helps when I'm writing this out here. So this would be f of x minus g of x when I'm setting up my integration. Okay. So then this would be the integral of -2 to 6 of 4x plus 12 minus x squared, okay, dx. This is the same as saying 4x squared divided by 2 plus 12x minus x cubed divided by 3, solved at -2 to 6. This is equal to 4 times 6 squared divided by 2 plus 12 times 6 minus 6 cubed divided by 3 minus 4 times -2 squared divided by 2 plus 12 times -2 minus -2 cubed divided by 3. And I type this whole thing in my calculator exactly as is. I make sure everything is correct. And then when I press enter, I get 85.33. And then the last example here says the curve to the right is the graph of the following equation. Find the total area of the shaded regions in the graph. Okay, well, first thing that we have to do is we have to find exactly where it intersects the graph here. So there's an intersection here, we know there's one here, and there's one around here. So to find the exact values, I'm going to take y is equal to -x times the square root of 324 minus x squared, and instead of y, I'm going to set this equal to 0. Well, when I set this equal to 0, since there's two things being multiplied here, the x and this whole square root here, that's the same as me saying -x equals 0 and the square root of 324 minus x squared equals 0. So I know that one of my values is x equals 0, which I see right here. I could clearly see it crosses at the origin. And then the other one would be 324 is equal to x squared. I squared both sides and then added x squared over. And then when I take the square root, I get x is equal to plus or minus 18. And I can clearly see that this is somewhere around that -18 and positive 18. So I know that I'm on the right track. Okay. So instead of finding the integration from -18 to positive 18, I'm going to just do the integration of just half of this, so -18 to 0. The reason why I don't want to do the integration of the entire thing is because I'm going to end up getting a positive value and a negative value based on these areas here, and it's going to look like the total area is equal to 0, which is not true. Okay, because we clearly see some things that are shaded there. However, I know that if I find one of these, I can take that value and multiply it by 2, and that will give me my total area. So I'm first going to find just the area from -18 to 0. So I'm just finding this part right here. And I'm going to take the equation, so -x this times the square root of 324 minus x squared dx. And then remember, I know that since I have that square root there, that I'm going to have to use u substitution. And I always let my u equal to whatever is under that radical. So let u equal 324 minus x squared, which means that du, the derivative, is equal to -2x dx, which means that x dx is equal to negative 1/2 du. Okay, this is important because when I plug it back in, I want to make sure everything cancels out properly and I'm not just adding random numbers in there. Okay, so I'm going to rewrite this in terms of u. I'm first going to take out this negative in front of the x because it's a coefficient and I don't really need it there right now. So I have negative outside of my integral. And then u is representing everything under that integration. So I'm going to end up getting the square root of u. And then I'm going to multiply that by negative 1/2 du because that gives me my x dx. So that takes care of these, this portion of the integral. Well, when I do that, I can also take out that negative 1/2. So I'm left with 1/2 integration of the square root of u du. Okay. Which means now that everything is in terms of u, I'm going to have to make my intervals in terms of u. And I know u is equal to 324 minus x squared. So this is going to be u is equal to 324 minus 0 squared, which gives me 324. And then on the bottom, that negative 18, this is u is equal to 324 minus negative 18 squared, which is going to give me 0. It's going to end up canceling it out. So really, I have 1/2 times the integration of 0 to 324 square roots of u du. Well, I could rewrite this as 1/2 integral of 0 to 324 u to the 1/2 power du, which means when I integrate this, if I add 1 to the exponent, this is u to the 3/2 power divided by 3/2, which is the same as saying multiplying by 2/3. And then I want to multiply this whole thing by 1/2 because I still had that outside of my integral. Okay. Well, if I solve this at 0 and 324, this would mean I would have, let's see. I would have 2/3 times 324 to the 3/2 power times 1/2. I don't have to worry about the 0 because everything's going to end up turning into 0. And I'm going to get the value 1944. But remember, that is only the area of one side of this curve. And the reason why I didn't do the integration from negative 18 to positive 18 is it would look like my value is equal to 0, which is not true. So I need to take my value of 1944 and just multiply it by 2 to get the area of both of the curves. And that answer is 3,888.